So this is the first problem, a wallet exchange. In the problem, it says Alice and Bob are both, they choose to do something. Alice has A coins in in her wallet and Bob has B coins in his wallet. Both people or both players take turns. Alice making the first move. In each move, the player will perform the following steps in order. So what happens in one move is the player will first choose to exchange wallets with the opponent or keep their current wallets. And after that, he will remove one coin from the player's current wallet, and the current wallet should not have zero number of coins before performing it. So it should have at least one coin. And the player who cannot make a valid move loses. So if both of them play optimally, determine who will win. And like just going through the guesswork, since this is the A problem, when you see the problem, you will try to do some guesswork, right? Okay, let's leave the guesswork for now. First of all, let's see what to do. Alice and Bob. These are the two players. Both of them have some wallet. Both of them have some wallet which has some money, which has some coins, and they will go one by one, make some move. Alice will go the first move, then Bob, then Alice, then Bob, and so on and so forth. In one move, they will decide whether to keep the wallets like this or exchange them, whether to keep their wallets on their own or exchange the wallets. And then Alice will um, take out one coin from her wallet. And then it would be Bob's turn. Bob will again choose whether to swap the wallets or just keep their own wallets. And then he will remove one coin from his wallet, whatever wallet he has after the move. So is the problem clear? Guys, please say yes or no in the chat and like be fast. Is the problem clear? Okay, great. Once the problem, okay, no, can you explain again? Okay, let me explain once again. So in the problem we have been given, Alice and Bob are two players who are playing a game. In the game, what happens is both of the players one by one makes their move. In their move, what happens is first thing is they choose whether to swap or not, like whether to swap their wallets or not. This is the one who is making the move will decide. And after that, once the wallets are either being swapped or not, whatever happens, after that, whoever is making the move will deduct or will basically pop out one coin. So if Alice has made the move, Alice will take out one coin from her wallet. And for doing this thing, she should have at least one coin in her wallet. And if at any point whoever wants to make a move, whoever's turn it is to make the move, doesn't have that many coins in his or her wallet, he will lose. Okay, so someone said this wallet exchanging thing confused me a little, or initially later got to know it is of no use, just what matters. Yeah. Okay, so is the problem clear now? Please say yes or no. Okay, clear. That's good. Deduct one point or remove one point basically. 1 point. Yeah. So see one thing. Alice and Bob both have wallets. Now let's say it is Alice's turn. Now, does it matter? Like, what do you think? When will Alice be unable to make the move? If it is Alice's turn, in what case will she be unable to make the move? Someone is saying, does the contest has a time already finished? Like, I don't understand completely. What are you willing to ask? Maybe we can discuss this and after the contest. Okay, if you see the sequence and contest, please, when both are zero. Yeah. Let's say that Alice has 0 coins. So yeah, she cannot remove a coin from her wallet. But if Bob is having any number of coins greater than 0, on the first thing of the move, Alice could have just swapped the wallet In that case, Bob would have got 0 coins and Elias would have got the number of coins which were available in Bob's wallet, and Elias can make the move. Similarly for Bob. So if any one of them is having greater than zero number of um, if any one of us having greater than zero number of coins in his or her wallet, then the move can be made. Anyone can make the move. But when both of them are having zero and zero number of coins, let's say it doesn't have any coin, it doesn't have any coin. In that case, whoever has to make a move cannot really make a move, right? The only case where the person cannot make a move is when both of them are having zero number of coins. So does this thing make sense? Are you able to understand this part? What if both are equal? Like it doesn't matter in that case. If Alice is having 7 coins and Bob is having 7 coins, Alice can just make a move. If Bob had to make a move, Bob can also make a move. The only case where someone is failing. Why are we trying to find it? Because we want to see when the game will end. So when both of them are having zero number of coins, this is the only condition in which both of like whoever wants to make a move cannot make it. So someone said, and what if they are initially equal? Right now we are not talking about what if they are initially equal or not, what if they have that many coins or what. We are just talking about when the game will end. Right now we are talking about it. We know that Alice will make a move, then Bob will make a move, then Alice and Bob. We want to figure out what will like when will be the case when someone is not able to make a move. So is this part clear? Okay. So we know when the game will end. Now, in the move which we have been given here, like we have been told that both of them are going to make the move one after the other. Every time one coin is being removed from the wallets, like from whatever wallet it is, whether from this wallet or from this wallet, one thing is common that one coin is being deducted. So if Elias had A number of coins and Bob had B number of coins, after A plus B number of moves, both of them will have 0 coins in the wallets. Does this make sense? Does this part make sense? That after A plus B number of moves, both of them will have 0 number of coins. So whoever's turn it is after that much time will lose. Okay, I think that this part should be clear. Now, okay, so now how to get after A plus B number of moves, whose turn would it be? Anyone willing to guess anything? If you know A, you know B, how will you figure out whose turn it would be after A plus B number of moves? You know that Elias will be playing the first move. Let's see. Let's take some case. What if A is 1 and B is equal to 2? Elias will make a move. Any one of them would get subtracted. It doesn't matter which one gets subtracted. Bob will make a move. Elias will make a move. They have played 3 moves, that is A plus B. After that, it is Bob's move. So you can observe one thing, like you can try out for A equal to 1 and B equal to 3 also. Then in that case, Bob would also be able to play a move and then Elias will fail. So if you try this out, you will notice that if A plus B is odd, in that case, Elias would be the last one to play a move. And when A plus B is even, then Bob would be the last one to play a move and Elias would have to play a move and wouldn't be able to move it. So can I say that, hey, if A plus B, like I will just check if A plus B is even or odd. If it is even, then Elias will lose, or basically we can say Bob will win. And if A plus B is odd, then Elias will be the winner. So does it make sense? Yeah, you can check for absolute of A minus B also, but this thing is more intuitive. Like we just discussed the whole intuition behind the problem also. Okay, so let's move on to the code. And by the way, at any point, if anybody has any doubt, feel free to ask it. So what we do here is just take up the inputs. find the sum. Okay, let me tell about the template also. So in the template, I'm taking the number of test cases as input, and for every test case, I'm running this solve function. And inside the solve function, like you don't have to worry about anything else. Just see the solve function. It is for every test case. I'm taking the number of test cases as input, finding the sum. If the sum is odd, then Alice will win. Otherwise, Bob will win. What is one is odd and one even? So if you see, we don't really care whether A is odd or even and B is odd or even. We only care about the sum. If you say that one of them is odd and the other one is even, then the sum would have been odd and Alice would have won. Does this clear it out? What can be the rating of this problem? It would be 800. The rating must be 800. Actually, it can be like it should be less, but Codeforces doesn't give a lower rating. It gives at least 800. So someone said that is some bitwise and one and some percentage two. For now, you can just think of both of them to be same. Though this one is a little faster, but it doesn't really create any big difference here. Yeah, it was actually easy. How did you reach to the conclusion that some even odd? Um, I reached to the conclusion, like in my case, I didn't really do all these steps, but if you try to solve the problem like this, it would have worked for you. The main observations which I asked to you, like you saw that both of them will play the move one by one. So the first question I asked was, when will the game end? When will the game end? We saw that when will the game end? After that, we did see, like, can we identify whose turn would it be? Whose turn would it be? So yeah, we could have, like, we were able to identify whose turn it was because we saw that after, okay, one more thing which you could have observed here is when Alice plays a move, then Bob plays a move. After that, again, Alice is having the turn. So two operations did nothing. It just subtracted the number of points by two. So after every even number of operations, Alice will again have the turn. You could have thought in this manner also. After that, once we got to know that whose turn it would be, we just got that the one whose turn it is would be the one to lose. So the other one would be the winner. This thing either you swap or reduce by one or not. Oh, your F1 passed. Oh, great. Okay, great. That F1 passed. Okay, so guys, shall we move on? Please say yes or no. Shall we move on to the next problem? Let me see. Is it passed? Okay, it did pass. Great. Okay, let's move on to the next problem. There are 40 people and only 2 people are writing stuff in chat. And only 5-10 people. Okay, so let's see the second problem. Plus minus split. In this problem, we have been given that there is a string of length n consisting of characters plus and minus. S represents an array A of length n defined by ai equal to 1 if si is plus and ai equal to minus if si is minus. Basically, they have given us something like plus minus plus minus minus plus plus something like this, a string where if the ith character of the string is plus, it means that it is like 1 for an array. So we are being given a string which is nothing but it is being given instead of an array. The plus represents 1 and minus represents minus 1. So like, is this part clear? Is this part clear? That instead of an array, you are being given a string. Just to make the things a little more complicated for the beginners, they gave a string where the plus represents 1 and minus represents minus 1. And what we have to do is we will process. Okay, we will do the following process to calculate our penalty. We will split this array into multiple non-empty arrays such that all of the arrays combine to the same array, come back to the same array. Like this, they have actually explained the valid and invalid partitions. And after that, once we have created some partitions, we will see the penalty of a single array is the absolute value of its sum multiplied by its length. In other words, or basically in more formal words, for some array C of length m, the penalty is gonna be equal to the absolute sum of all the elements multiplied by its length. And the total penalty for the whole array or for the all the partitions would be the sum of all those partitions, the penalties of all those partitions. We want to perform the above process optimally and find out what is the minimum possible penalty which we can get. And they have given some valid splits. Like if we have 31415, we can split it into 31415 or 31415, 31415, like this. You can read it out. Okay. So like, is this part clear? And let me explain it once again also. Okay. You have the array. Let's say the array is something like 31415. You can partition it into some parts. Basically, it's like subarrays. Like you partition it like this. You can relate it to subarrays or in any way you want. After partitions, the array can look like this: 3, 1, 4, 1, and 5. So is this clear that how we can partition it? You cannot really partition it. Like I can, let me show you one invalid partition also. You might say that, hey, I will take 3, 1, and 1, 3, 1, 1, and 4 and 5 in the other partition. So this is not a valid partition. You cannot do this thing. Yeah, I will explain the multiplying part also. Okay, so I hope that the partition part is clear. The first thing which we can do from on the array. After that,
Can you please repeat partition?
okay, so what part is not clear in the partition thing?
नहीं समझ नहीं आया.
Okay, so let's say you have an array like 3, 1, 4, 1, 5. What partition says is you can just divide this array into some parts. The uh, parts can be like all the elements. Basically, like, do you know what subarrays? I think that people would know about subarrays. So you can just divide it into some subarrays such that all of the elements of the array would be covered. So an example is you take out one of the subarrays 3, 1, another subarray 4, another subarray 1, and another subarray 5, like this. Or if you wanted, you could have done something like taking these two together also: 3, 1, 4, 1, and 5, like this also. So
Okay, so basically we need to create different subarrays.
yeah, we can just create any subarray. We like uh, partition it into some subarrays. It's up to us in what way we want it. And okay, so partition part, is
I
it
have
clear?
one doubt
Yes.
in the question. In there in input section, one lies in one line. I am very much confused. Note that there are no constraint on the sum of the n overall test cases. Like the value of n is given between 1 to 5,000. So can I apply here big of n square approach?
No, you cannot.
Why? The total sum would be 5,000, so I can apply na.
No, n can be 5,000. They have not said that the sum would be 5,000. For every test case, it can be 5,000. So the sum overall can be something like 5,000 into 1,000, which is nothing but
what
5d6.
what does it mean by this sentence? It comes in the multiple contest. Note that there are no constant on the sum of an overall test cases.
They are just clarifying that, as you see that most of the times they tell that there is some constraint over the sum of n over all the test cases, just for clarification that because
What does it mean? What is the difference between this line and this line? Please explain with the simple example that in the future I will be it will be helpful for me.
okay. So okay, like I think that I will discuss this after the session. Right now this is very relevant.
Okay, okay.
Are you in level 1?
No, I am not in level 1, but थोड़ा
Okay,
confused हो गया था
let's
उस
leave it
time
for now.
मतलब.
Let's leave it for now. Okay, so we were at the process. In the first part, we saw that how to uh, create partitions or split the array into some partitions. Right. In the second part, we can see that the penalty of a single array is the absolute value, like absolute value of the sum multiplied by its length. So if you have an array like 1, -1, 1, -1, -1, if this is an array, the problem says that take out its sum, what would it be? Okay, let's write in chat. What do you think? What would be the sum? 1 -1, 1 -1, -1. The sum should be -1, right? And the length of the array is 5. So multiply it with 5. We have done the sum into the length of the array. Now whatever value you get, just take its absolute value. So if it is a negative value, just multiply it with -1. So it will become 5. It basically means just pass it through absolute. If it is something like absolute -5, it becomes 5. Okay, so is this thing clear? How we count the uh, penalty of a single array? Is this part clear? Guys, say yes, no in the chat. And okay, we know how to find the penalty of an array. After that, we are being told that the final penalty or the complete penalty, whatever word that they use some word, total penalty. Total penalty would be nothing but the sum of penalties of all the partitions we created is equal to the sum of penalty of all the partitions we created. Okay, so is this clear? And let's call it as TP. We want to minimize this TP. We want to minimize the total penalty. Okay, so I think that it is clear. In case if anybody has any doubt, you feel free to ask it. And okay, since someone mentioned this, let's look at the constraints also. We are being told that there are multiple test cases, and we are being given the number of test cases first, and then for every test case we are being given the length of the string, and then we are being given the string itself of length n, and there are no constraints on the sum of n overall test cases. So the number of test cases can be as much as 5,000 into 1,000. Is this part clear? Everything till now? Okay, great. So here, let's see. You want to minimize this TP. What do you think? What should I do? I have to create some partitions in which the TP would be minimum. Do you get some intuition, or let's see if we can get some idea from this part? The penalty of an array is nothing but the sum of the elements multiplied by the length. So I definitely want to have a smaller length because multiplication can be very bad for me, right? I definitely want to have a smaller length since I want to minimize the total sum. I want to minimize the length. And second thing is, if the sum is 0, if I could somehow make the sum of, like if I could somehow make a partition whose sum is 0, then sum into m would be 0. if I could somehow make sum of some partition equal to 0, if I could somehow make some partition like this, then multiplying it with them would also be 0. So I will be able to like reduce my total penalty. If I have something like 1 minus 1 1 minus 1 minus 1, in this case I can do something like this: take these two together, take these two together, and this one is left. I cannot really um, have it as a part of a partition whose sum is 0. So I would have to take it only one alone, and it would have a penalty of 1. So the total penalty here would be just 1. For me, absolute KBC, yeah, it will KBC. Yes. Okay. So this is the intuition which we were getting. From here on, you can actually look at the test cases. Like if you're experienced, you would have already got the idea of what to do. But otherwise, you can just look at the test cases to confirm. In the test cases, they gave some test cases which, after reading which, you can do some guesswork also, even if in case you don't get any intuition. So here, in case if you have plus minus something like this, you will just pair them together. You will just pair these plus and minuses together so that you will have second. Yeah, you will just pair plus and minus together so that you will have minimum penalty. If you have multiple minus 1, yeah, you will get the recording of video on YouTube. It is gonna be announced in the announcement session. That no matter how we partition, the final penalty is the same as the penalty of the original. Yeah, you can say something like this, but for a beginner, that intuition which you are saying right now might not be very obvious. So that's why I'm keeping it very simple, like which any beginner can think. How a beginner could approach the problem. Okay, let's see minus 1, minus 1, minus 1, minus 1, minus 1. If this is the array we have, which is being given in the third example test case.
Can you please explain the first line, like the first line, point number 1 in the question?
This one.
Yes, yes.
Okay, so it says that you can split the array into some non-empty arrays b1, b2, b3, and so on till bk, such that b1 plus b2 plus b3 till bk is a, where plus is the array concatenation. So if you have an array like 3 1 2, you can split it into 3 1 and 2. Like you can do any concatenation such that after, like any partition such that when you concatenate them, like if you just concatenate these together, you will get 3 2 back, right? So you can do any such partition in which after concatenation you will get the original array back. Is your doubt clear?
In that line, it is written a to the power of plus. So I got confused. What does that mean?
No,
Equals.
no, no. This is just a symbol because they have written this and then they have shown this. They have given some valid ways of splitting and some invalid ways. This is just for the example stuff. Okay, no problem. Let's see this now. If you have minus ones together, taking a bunch of minus ones together will just do bad for you because the sum would become 2 and the length would be 2. It will give you a penalty of 4. But if you take them 1 and 1 alone separately, then you can get a penalty of just 2. If you take this guy, it will have a penalty of 1 and this guy will also have a penalty of 1. So the overall penalty will be just 2 for these two elements. If you once you notice this part, you can just get the intuition that the ones you have, just try to pair them with minus 1. For all the ones, try to pair them with minus ones, and all the ones or minus ones which you are being left with and you cannot pair them, for them you just take them in the partitions of 1 1 element, which will give 1 1 part, a penalty of 1 1. So at the end of the day, if you had plus number of ones and minus number of minus ones, then whatever the minimum of these two is, plus and minus, you can make these many pairs. I just made a claim here. Does this thing make sense to you guys or not? Please say yes or no.
No,
Then
but we cannot change the order, right? It should be sub-array. We
yeah,
cannot take them
okay,
anywhere. Yeah.
yeah, absolutely. You should get this question. So let me show you a claim. Let's say you have a bunch of ones coming, then a bunch of minus ones coming, and then a bunch of ones coming. Let's say ones are in majority. The number of minus ones you have, you can just take out some ones from here and some ones from here, or maybe just a complete block of ones from there, such that the number of ones and minus ones would be equal in the subarray. You can try to do this, and you can try to think about it more. You will come up to the conclusion that it is always possible to pair up all the minority elements. If minus 1 is less, the number of times minus 1 comes is less than number of times plus 1 comes, then for every minus 1, you can just have it in a subarray where the number of ones is equal to the number of minus ones. Let's try this thing. Let's try this thing out. Here in this case, the minus ones are in minority, right? Let me zoom in a little bit more. Minus ones are less. You have two minus ones, take out two of the plus. And here you have a minus one, take out one of the pluses. So you got rid of these guys without getting any penalty. You got a penalty of 0. You are left with 4 extra 4s, and your answer is just by 4. Here again you have minus ones in minority. So you have 3 minus 1. Try to find out 3 pluses around it. This one and these two. Just got a partition, got no penalty, and got rid of it. Now here you have 3 minus ones. Try to find out 3 pluses around it. You found this guy and these, right? For this minus 1 and this plus, you got rid of it again. For this minus 1, just get rid of a plus around it. You got 4 pluses left. That's why the answer is 4. Yeah. So guys, does this thing make sense? How it works? I have not really proved the thing. I have given a claim. You can try to think about it more. It is not hard to like accept. Okay. So the major part has been done. You can try to think of some more cases to just satisfy yourself that it is always gonna be possible. You should be able to visualize this part. Okay. So we saw that we can just the wait is over for C. Yeah, we are going to for C after this. Okay, so we got that for all the elements of the minority, we can just pair it with the elements of the majority, the element which is coming more times. So whatever is coming more number of times, let's call it as mx. Like let's call its frequency as mx, and whatever is coming less number of times, let's call its prefix like um, count as mn. So from the one which is coming in majority, the one which are coming in minority would have paired up with this many people from the majority. Okay, let's take an example. You have plus coming 7 number of times and minus coming 3 number of times. These 3 minuses would have paired up with 3 pluses. So eventually you will have only 4 number of plus left which are unpaired. So the answer would be nothing but mx minus mn, right? And in simple words, you could have said the absolute difference of plus and minus. Now, these two things are the exact same things. In case if you're not able to figure this out right now, try to think about it more. It is very simple thing. So then why subarrays should multiply with them? You will never have any subarray with an absolute sum other than like all the subarrays which you create would be of two types. We got this. We have actually seen this thing. We have already got the intuition of why we do this. For all the subarrays, you will either have its sum equal to 0. And in case if you cannot create a subarray with sum equal to 0, then in that case, you will create it with length 1 so that it will have only a penalty of 1. So whatever number of extra elements we have, we will just pair them, like partition them to be the um, only one element in the array. So if you have something like 1, 1, 1, 1 in an array, you will partition it like this. It will become 4 small arrays. Okay, so guys, is this part clear? Like the problem is clear?
In that example, 7 and 3, 7 plus and 3 minus, which you took here.
Yeah.
So 3 minus will cancel 3 plus, right? So only
Yeah.
1 plus will be okay. The
Uh,
4 plus will be remaining. Okay, okay, got it. Thank you, thank you.
okay, great. So let's see the code. And guys, what's your feedback? Today I've been going very slow so that even the ones who are not very comfortable right now at CP can very well understand things. What's your opinion on this? You can write in the chat. And let's see the code also. We are first of all taking the inputs, then counting the number of plus and minus in the array, and actually not even creating the array, just taking the count from the string itself. And after that, printing the absolute difference of plus and minus. So shall we move on to the next problem?
How can we make like these observations like this comes over with practice? I think such observations.
Yeah, honestly speaking, I've been trying my best to um, show, like, ask questions again and again of what to do to identify, like, in this problem, we saw that we want to minimize TP. So what will you do? What can you do? Like in this kind of questions, try to ask yourself more and more. I want to minimize this thing, so what can I do? Either you can try to make it 0 or you can try to minimize this thing. And similarly, if you have something like multiple ones left, what can you do? So try to think about these things. Okay, let's see the next problem now. So this is the third problem. Grouping elements. Sorry, grouping increases. In the problem, we have been told that you are given an array A of size n. You will do the following process to calculate your penalty. Split array A into two possible empty subsequences S and T such that every element of A is either a part of S or T, like either it comes in S or T. And for an array for an array B of size M, define the penalty PV of an array B as the number of indices I between 1 and M minus 1, where Bi is less than Bi plus 1. Okay, let's actually see this here. So it is like we are being given some string, or sorry, not the string, but an array here. Yeah, you are being given an array. You are being given an array. From the array, you will take two subsequences S and T. What are subsequences? Just take out some elements from the array in the same order. Any elements like this. If I just pick up these four elements from the array, this will be a subsequence. So you have to take out two subsequences S and T such that all of the elements are coming in exactly one of the subsequences. And we uh, we say that the penalty of an array B, let's say, like when you took a subsequence S and T, both of these are arrays in themselves. So the penalty of this array would be the number of pairs where an element is smaller than the next element. Okay, let's take an example. If you have something like if s is equal to 1 2 1 7 3 4, what would be the penalty? Write in chat. What do you think? I was just solving this. Why we cannot just find the number of elements which are less than the consecutive? It won't give you the best. It won't give you the best answer. Okay, 3 3 2. Let's see. This is 1. This is the first penalty. Second penalty. Third penalty. We are having only 3 penalties here, right? So I hope that penalty for an array should be clear. How we define the penalty of an array, and the total penalty which we receive will be equal to penalty of s plus penalty of t. If you perform the above process optimally, find the minimum possible penalty you will receive. So we have to create um, two subsequences s and t such that the total penalty, let me write it as TP here again. Okay. Yeah. Such that TP should be minimized. Is the problem clear?
Can you please explain those 3 points again?
Okay. So in the first step, we just split the array into two subsequences, S and T. I hope you know about subsequences. We just split it into two subsequences. Every
Yes.
element of the array should be a part of either S or T. Then we say that the penalty of a subsequence, or sorry, a penalty of an array would be the number of pairs uh, Si less than Si plus 1. Like wherever you see that an element is smaller than the just next element, like 1 is smaller than 2, 1 is smaller than 7, 3 is smaller than 4. If you had another element here, let's say 5, then this would have also been a pair. 4 is smaller than 5, and the count of this these pairs is the penalty. Here the penalty would have been 4, and the total penalty would be the penalty on S plus the penalty on T, and we want to minimize this thing. We want to minimize the total penalty. We have to minimize the penalty, so answer could be total minus 1. Yeah, we have to minimize the number of penalties. That's the main thing which we have to do. So I hope that the problem is clear now. Let's see it. Let's see what to do now. If you have something like 1 2 3 4 5, like
What
what
does
question?
what does it mean empty subsequences in the point one? It's confusing there.
How can it be confusing? Like empty subsequence. What do you understand by subsequence? You know that a subsequence might not have any elements. If you have a string 1 to ABC, an empty subsequence, a subsequence without any element, is also a subsequence. This is known as the empty subsequence. So we are being told that the two subsequences we take from the array, the one of those can be empty also. Okay, so let's see this now. We want to have like we don't want to have bi less than bi plus 1. Like we want to minimize this thing as much as possible where b is an array. If you have the subsequences s and t, then you want to minimize si less than si plus 1, right? Something like this. Now for the problem, you can try to think about the stuff coming in your mind. You can try to think about the intuitions first. After everything, like everything I tried, I could not get to any good uh, any good intuition or any approach. Then what I did is, it is something like, just imagine, like I did something else, but it the solution I'm telling you here is more reliable. Just imagine that you have already put up the first I elements from the array into the subsequences s and t. Now you don't know in which order you have put. Just imagine that you have put it in some order. To see what will you do the next, like how will you decide the next one? Guys, what do you think? Let's say this is my AI. This is the element AI plus 1 now. I have put up some elements in S and some elements in T. Now I want to decide whether to put this AI plus 1 in S or in T. What will happen? Like on what basis should I decide? You have 30 seconds to think about it. Just try to think about it for 30 seconds, then I will tell you. You will compare the last element, put it. Okay, very well, Dhruv. Good idea. And Adi also, correct idea. Okay, so I think that you would have got some intuition, like you would have at least got some idea if you have tried to think. Now, just look at this. In the subsequence S, whether you put this element here or not, does any of these elements bother about it? Like, does it affect any of these elements? Whether I put this element here or not, does it, like, does these have any effect? You will see that no, they don't really have any effect. If there was something like 1, 2, 3 in the subsequence, and you are about to put up a 4, these elements doesn't really care about it. They don't really make any change. Whether there was a 1, 2, or there was something like a 4, 2, or there was something like a 4, 7, it doesn't matter. Can I say that if it doesn't matter, then I don't have to worry about the whole subsequence? I just have to worry about the last element in the subsequence I put. I only have to worry about the last element because this is all which matters. If there is a 3 at the end and I put up a 4 in the subsequence, then I will get the penalty increased by 1, right? I will get the penalty increased by 1 because I got a pair of 2 elements, consecutive elements, where the second one is greater. On the other hand, if instead of this 3, I had a 7, in that case, I won't get a penalty, right? I won't get a penalty. So all what matters is the last element of the subsequence, right? Let's use this observation here. So now what we have seen is, if we have considered some elements of the array, we have to consider a of I plus 1 next, or let's say just a, it would be easy to write. The two subsequences you have S and T, you only care about the last element of these. You only care about the last element. Let's call it as S dot back. Basically, I'm talking about the last element of the subsequence of S and T, right? This was the main intuition. We just try to think that, just imagine if you get to the solution somehow and you are in the middle of the way, on what basis will you go ahead? If you have already covered this part, if you have already somehow decided how to put up the first few elements, how will you decide how to put the next element? We try to
S
think about it. Huh?
S dot back should be greater than AI, then we'll put in S. Or if T dot back has the element greater than AI, then we'll put in T.
We will see this. Like for now, we have actually talked about the intuition, which would be coming up handy in a lot of problems, not just this one. That if you're not getting any intuition of what to do, or you're not able to have a starting point for your approach, just imagine that if you somehow are able to do some starting point, how will you decide whether to, like, what to do after it? This is a very important thing, and it can be useful for a lot more problems. Like this is the learning part of the problem now. Okay, so you see that it doesn't matter what the subsequence is. What matters is the last element of the subsequence. Now just imagine that the last element is 3 for the string s, and sorry, the subsequences, and for the subsequence t it is, let's say, 7, and you want to put up the value of AI is 10. So guys, what do you think? What should I do now? Where should I put it? Whether in S or T? Can we get, like, can we decide now? Earlier it was very hard for us, but now is it easier for us to decide on?
Anywhere we put, we will get a penalty here.
Yeah,
Anywhere.
yeah,
Yeah.
very good observation. So the observation here is we are bound to get a penalty. So wherever we put, we are bound to get a penalty. Just imagine if I put it here, what will happen? The new s dot back would be 10. Sorry, it would be 10, and the t dot back would be 7. The last element of s and t would be 10 and 7. If I put it in the subsequence t at the back of subsequence t, then the new last elements of the subsequence s and t would be 3 and 10. Which one do you think is better? Is this better or is this better? The only difference here is that I will have a 3 here and a 7 here. This is the main difference. Yes, definitely. This one looks better because I want to have larger elements at the back. Because adding an element which is larger than the back will give me a penalty. So I want to have larger element already, right? No, largest decreasing subsequence would not work here. And for now, I don't think that I should spend time in explaining this right now. I can help you out with this thing after the session. Okay, so this part is clear. We have very well got the intuition and have understood how to get to this part. Like um, putting it on the place with the smaller element is definitely better. Now just imagine that if instead of this 10, let's see this part, instead of this 10, I had to put up a 2 here. Where should I put it? Like the last time, we can have one observation here. We don't have any penalty wherever we put it. We don't get any penalty. Let's say I put it here. I will have 2 and 7. If I put it at the back of t, then I will have 3, 2. Which one is better? This one is better, of course. So we got one thing clear. If adding is not really like in both cases, either we don't have any penalty or we have penalty, it is better to put it at the position of the smaller element. Right? This is clear. Is this part clear? That if AI is greater than maximum of s back and t back. For now, like I'm just calling s and t. You don't even have to maintain a subsequence. You just have to maintain two variables s and t. So if it is greater than both of them, put AI at the back of the smaller one and increase the penalty. So the minimum, whatever the minimum one of them is, in at the place of that, just put up AI and increase penalty. In case if AI was smaller than or equal to both of like any one of them, the minimum of them, basically smaller than or equal to both of them. In that case, again, replace the minimum one because minimum one is better for us, right? And penalty won't be increased. Now imagine that here you see that S and T are 3 and 7. If AI was equal to something like 5, obviously we have only these four cases. If um, like either AI can be greater than both of the elements, or it can be smaller than both of them, or it can be in between, right? We have only these four cases and we have discussed this part and this part. Now guys, what do you think? What will happen in the third part where AI is greater than 1 and smaller than 1?
Wherever it is smaller than the other, there it will go.
Okay, okay, wait. Someone said that I show a pen, like someone wants me to show a case where if we had put up this 2 like this, the worst way, then we get some extra penalty. So just imagine if AI plus 1 would have been equal to 4. In that case, now you would have been forced to uh, get a penalty, right? If you had replaced 2, if you had replaced 2 with the larger element, then you would have got a penalty on the next element in this case. Whereas on the other way, if you had replaced this 2 with the smaller element and had got something like this, then you could have been saved from a penalty there. So Adi, is your doubt clear? Like, did you ask for this thing? Why can't we put 4 at the place of 3? Yeah, you can put 4 at this place, but it will give you a penalty. 4 is greater than 3. You can put this 4 here, but you will get a penalty. Yeah, okay, great. So you got
Can
it.
you explain the case where we are putting AI and both are greater than AI?
That's the same case which I did show right now. Both
I
of
mean, I
these are
mean, both
greater
are
than,
less. Both are less than AI.
both are less than AI. Okay, just put up a 10 here. Like, just do the same thing. You just put up a 10 here. If you replace this guy, then you would have got 3 and 10. Like, instead of this, uh, it was 3 7. Just imagine if you put up a 10 here, you got 3 10. Then let's say the next element was something like 4, you would have got 3 4. And then the next element, okay, wait, let me see it once again. Okay, so if the next element is something like, yeah, if the next element is 6, you would have got it reduced, right? Or maybe let's just take 5. Yeah, let me show it once again. Okay, so you had 3 and 10, 3 and 7. Let's say you replaced 7 by 10. So in that case, you would have got 3 and 10. Then let's say the next element is 4. So you would have got 3 4. You would have replaced this 4, this 10 with 4. Then next element is 5. In that case, now you are bound to use a penalty. Like now you are bound to get a penalty. Whereas in the other way, if you had got 7 and 10 at the as the two elements, when you got the 4, you could have replaced 4 and 10 like this. And then when you got the 5, you could have got 4 and 5. So there is no penalty in this case. Yeah, okay. You got this? Great. Okay, so we have understood both the cases of AI being greater than both of them or being less than equal to both of them. Now, what if it is something like 5? Now, in this case, it is very straightforward. If you just replace this 3 and get something like 5 7, you are getting a penalty. You are getting a penalty right now. Whereas in the other case, if you replace this 5 here, you would not, at least for now, you would not get a penalty. So, not getting a penalty right now is not really doing anything bad. And if you like just take up a penalty right straight away, if you just straight away take up a penalty, it's not confirmed whether you would save a penalty for future or not, but you have definitely got something bad for now. So yeah, it is optimal to greedily pick. Yeah, this is a greedy problem. So here we greedily decided what to do. So in case if the current element is greater than one of the guys and smaller than one of the guys, then just take up the greater element and replace it with it. So 7 is greater, just replace 7 with 5, or basically add 5 at the end of the subsequence. So the next element will be, next smallest will be 5. Sorry, next large element at the end would be 5. Can you prove that greedy will work? Okay, so we really did prove for like not completely proving it mathematically, but logically we saw that um, making the smaller element equal here and here is the best choice which we can make. You don't really have a lot of choices. You only had two choices, right? You only had two choices. We definitely saw that in both these cases we were having a better choice, right? So like you can logic you should be logically satisfied that I only had two choices, either put it at the end of the S or T, and we took the better choice for sure. But now in the case if you had a choice in getting a penalty and getting to a state like 5-7 with like getting a penalty and the state versus not getting a penalty right now but being at a state 3-5, so which one is better? Now I would say these 5 and 5 are equal, so it doesn't really have like it is not a big change. The only big change here is you got a penalty but you have a larger element, you didn't get a penalty but you have a smaller element. So you see, if you get the next element smaller than equal to 7, then you can actually replace that element, but like you can just put that next element without getting a penalty. Whereas in this case, whatever the next element is, even if it is 7 in like 10 raised to the power 9, you can just put it at the end of 3 and get a penalty. So like this is kind of a proof that this state can definitely get to a better place than this guy, because here you have already got the penalty. Whereas in this case, if you get a very big number, only then you will be getting a penalty. So I hope that this is a good enough proof. I'm not going on for any mathematical proof, and obviously you would never go to a mathematical proof doing all this either. Okay, how does avoiding penalty at each step ensure I have the most optimal answer at the end? What if? Okay, let me give some example. Okay. Let me give you an example. Let's say I had 3 and 7 at the end, and like I have already processed some array. Now the next elements of the array are, let's say, 5 first. Um, we can have two cases. Either you uh, place 5 at the end here or here. Just imagine you place it at the end of 3. You didn't get any penalty right now. Now the next element is 10. Here in
It's
this
a
case,
penalty, right? If you place it
sorry,
beside
sorry,
3.
sorry, sorry, I wrote it at wrong place.
Yeah.
You placed it here. Now the next element is 10. So you can place it at this place. You got a penalty here. Yeah, you sure you got one penalty. But now the state is 10-5. If you had chosen the other way, if you had after 3 and 7, if you had placed a 5 here, now once you get a 10, you are again bound to get a penalty. You already got one penalty and now you are again getting a penalty. Just imagine if the array just ended here. There is nothing after this array, like nothing after this element. So you definitely just got two penalties, which one of which could have been corrected earlier, right? And like for any for any sequence you try to think of, you can try to think about many sequences. In every sequence, you will see that either you save a penalty, either you get one less penalty, or you get to um, either better state or just the same state. You will never get a worse state.
Can you explain the case where there is 3 and 7 and then 10 comes, but both will give penalty wherever we keep the 10. So where should we place the 10 then?
Um, like I didn't understand what are you asking right now.
We have
You
3 and
are
7. 3
yeah
and 7 we have initially for
yeah.
S and T. At the end 3 and 7 we have 10 is coming now. Wherever we place 10, we'll get a
Okay, so
penalty.
you
So
mean
where
that
should
five
we
doesn't
place
come
10 then?
first? 5 doesn't come.
Nah, 5 doesn't come.
Okay.
Only 3 and 7 are there at the end, and now we are bringing 10.
Okay. You have a 3 and a 5, and then you are bringing 10. So like I did discuss this part earlier, that just place it at the element just after the minimum one. And why we place it, it is very obvious, because if you place it after 5, in that case now you will have 3 and 10 as the last two elements. If you place it after 3, you will have 10 and 5. So like this is something you can just say, it is this one is better by just looking. Yeah. And similarly you can have said that what if we have a 2? So again, just placing it after the smallest element is better right now also. So is your doubt clear?
Yes.
Okay, great. So let's see the code now. Yeah, let's move on to the implementation. So okay, my implementation is very bad. Let me show you how to implement it now again. Like I will show this one, but it is just bad. During the contest, I wrote a bad code because I wanted to just submit it fast. Okay, now how do we decide the first step?
1 minute, 1 minute. If we have 3 and 5, and if we place 10 beside 5, it's still good, right? Because the next element we can place beside 10 and it will be less than 10.
No, no, no. 10 5 is definitely better than or equal to 3 10. Like you can just you
Yeah,
don't
if
even
we have
need it.
310, then
Yeah,
if we get
yeah.
7, 8, any other element, we'll put beside 10 and then we don't have penalty.
No, I'm saying that like if you try to prove your greedy solution, you definitely know that this thing is not bad. You don't even need to prove it. But even if you try to prove it, you can actually come up to some case like in 310. What if the next element is you get a 4 and you get a 5? Like once you get a 4, so you would have to place it here. After that, once you get a 5, you now have to get a penalty. Neither you can place it in front of it or this. But if you had 10 and 5, you could have placed the 4 here and then you could have placed the 5 here without getting any penalties. Right? Right? Hello?
Yeah, yeah.
Yeah. Okay, clear?
If we have 7, 8,
For now, we cannot really dry run so much. Like I've already shown a lot of time. I will show this after the session now. Like
yeah, yeah.
for random ideas, I will show it after the session. Like nothing will be different for 7 8 also. You would never have it bad. I mean, where to put this in? Okay, okay, good enough. So for the first element, whether you put it here or here, it doesn't really make any difference. It won't give you any penalty, right? It will give you no penalty, and you can place it anywhere. So one of the things which you might have seen many people doing in the problem, like in the contest also, is they just assume that the last element of the sequences are right now n+1. Why? So that you just wrote one generic code. Whatever you place here will not give you penalty, and you can just place it anywhere right now. Saying S1 equal to A1 and T1 equal to A2 is not a good idea. If you have something like 10 9 as the first two elements, then placing them at the front of S is better than placing them as this guy, right? Because here in this case, if you get an 11 after this, you will have to get a penalty. But if you had to place these two elements like this, you could just safely place 11 without getting any penalty. Okay, so I hope that it is clear. We can just place the first element at any of the places. And since the first element, like whenever you place an element, like whatever the first element of the subsequence is, doesn't give you any penalty, or either you can write some if else conditions, or you can try to just give out n+1 as the first element. Just assume it. Like it's up to you. The implementation is pretty straightforward now. If you don't understand why I am putting n+1 right now, just try out putting up if else conditions. Okay, so you have this array, you will go from left to right. For every element, you will have some choices. Either it is greater than the maximum of s and t, or it would be less than equal to the minimum of s and t, or in the else condition, it would be between both of them. So in this case, if it is greater than both of them, we just say penalty plus plus, and whatever the smaller element of SNT is, just say it to be equal to the AI, I will not take D, I will take F1. Okay. If it is smaller than or equal to the minimum of both of them, then you will just again say low equal to AI. And in the other case, you will just say high equal to AI. Why we do this, we have already discussed this in depth now, in detail now. Okay, so let's see the F1 problem. Is this fine? Guys, is this fine? Now coding it up is not hard. If you're at least if you are coming up for the C problem, it is expected from you to be very comfortable at running up for loops and if else conditions. Right. This is nothing but some if else conditions. Now the code I wrote with if else conditions is not so clean. During the contest, I wrote some bad code and because I wanted to submit it fast, so I didn't really erase it and write it again. So I just said that if it is greater than both of them, answer plus plus and assign the smaller one as AI. In case if one element is greater, one element is smaller, like for this, sorry, if both of the elements are greater, these if else conditions take care of that. In case if one is greater, one is smaller, these if else conditions take care of that. Now the code quality is very bad, so I'm not really reading it out completely. How do you think this was in terms of reading? The problem was not really hard. It was just the starting was hard to think. It was hard to think on how to start. So if you were smart enough to think about this idea, this is a very good idea. That just assume that you have already put up some elements from the beginning and now you have to decide how to put up the next element. And then in that case, the problem is just easy peasy. I have explained it I have spent a lot of time in explaining so that even the ones who are not so good right now can understand. But if you are good enough for C problem, it won't take you more than 5 minutes after getting this idea and the three cases. So it was like 5 to 10 minutes once you get to that idea. Before that idea, whatever time you spend will be just wasted. Like in my case, I wasted a lot of time there. Okay, so let's move on to the next problem. This is F1. This is the final problem I will be discussing today. Wine factory. So let me tell you right now also that this is a hard problem, at least a lot harder than the previous problems. There are some prerequisites. Let me write the prerequisites first, and then the ones who don't know about them can actually leave right now. Prerequisites. So you must know about segment trees or any similar data structure which can actually do the range queries. I think that segment trees is like I only know use segment trees, and I don't think that others would be able to do. So basically, you need to know about segment trees, and that's it. If you know about segment trees, I think that you would already know about the simple stuff. But you should know about generic segment trees, like having multiple things in a node. In case if you don't know about it, you can still watch. So this is the main prerequisite. The problem says there are three arrays A, B, and C. C has length n minus one. A. Will you explain E also? Sorry, but I didn't solve E. I didn't even read E actually. I was able to solve only A, B, C, and F1. There are three arrays A, B, and C. A, B have length n, and C has length n minus one. We say W of A, B, C denote the liters of wine created from the following process. The process has been given like this: create n water towers. The ith water tower has AI liters of water and has a wizard with power bi in front of it. Furthermore, for each I from 1 to n minus 1, there is a valve connecting that water tower from I to I plus 1 with capacity Ci. Here in this problem for F1, Ci is very huge, so you don't really need to worry about the array C. For each I from 1 to n in this order, the following happens. The wizard in front of the water tower I removes at most bi liters of water. from the tower and turns the removed water into wine. And in case if I is not equal to 1, like for all the water towers except the last one, okay, some people said yes. Yeah, okay, some people said thank you. You are welcome. And thanks for the session. Can you give some general advice for the people who are AB and this practice? I would say that try to solve C. You have already seen the tutorial, so it should be easy for you to now do the rest of the part. Okay, so if I is not equal to n, and in that case, at most Ci liters of remaining water left flows through the valve into the next water tower. Here in this case, Ci is very huge, so you don't really need to worry about this line either. There are Q queries in each update. You will be given integers p, x, y, and z. You will update AP equal to x, BP equal to y, and CP equal to z. After each update, find the value of W, ABC. Note that. Okay, so after every update, you will just find this thing. And we have been told that updates from one query will persist for future queries also. So this is the problem. I think the people who are coming up for this problem would have by themselves understood it. So I'm not really explaining a lot here. Then we have been given the constraints. So notice that Ci is 10 raised to the power 18 and Z is also 10 raised to the power 18. So you will never have any problem. You will never have this limit being a problem for you. You can just transfer unlimited amount of water. It is like unlimited amount of water since we don't have that much water also. So you can just ignore this RAC and know that Cn doesn't exist. Yeah, Cn doesn't exist. There is only of length n-1 for the RAC. So what do we have now? Let's see. We have an array A, which is like having some water towers. Each of the water towers are being connected by a valve. The capacity of the valve is being given to us in the array C. Every value of Ci is 10 raised to the power 18. So we are just neglecting array C for now. And we have been given an array B, which tells us that there for every water tower, there is a wizard which can take at most Bi amount of water from the ith tower and convert it into wine. And it's up to you that whether like once the water is being converted into wine, you can just take the water to the next water tower and similarly just take it to the next water tower again and again. And we have to find out what is the maximum amount of wine which can be generated. And there will be some updates also. So you will have some updates in the array. Now, one thing is clear that since we have some updates, some point updates, something like DP is not going to work out, right? Neither graph trees looks good here. Like this was my mentality here that graph DP trees doesn't work out. We have to make up some updates. It looks like a range query problem. It looks very similar to that. So I started to think about segment trees. Like from this part, I actually started to think that whether I can apply segment trees here or not. So, and let's understand what do we like, how will we calculate this WABC part? We will see how to make updates later on, but for now, let's see if we can actually find WABC using segment trees. So for any tower, what will happen? You have some water, in it. It is being removed. Bi amount of water is being removed and converted into wine. So if this water, the amount of water which was actually AI initially, if AI was greater than Bi, in that case, You had some water, you took some of it and created some wine. Now you will have AI minus BI amount of water remaining. What can I do with it? I cannot really convert it into wine anymore. So I don't really have any other choice. I just have to take it to the next one. I just have to take it to the next water tower, because here you don't have any others have any scope left. But there is a possibility that there is a possibility. Just assume that the next water tower, the wizard on the next water tower is having pi plus 1 amount of energy left. Let's take some numbers actually. Let's say you had 7 liters of water here. The wizard could convert only 2. So he did convert 2 liters of water into wine, 2 liters of wine. And now you are having only 5 liters of water left. If you keep your water at this place, it is not really going to do anything. And you don't really have any constraint on what this water pipeline or whatever you say, the valve. So just take it to the next water tower. It is not doing Taking this water to the next water tower is not doing any bad thing. So just take it to the next water tower. Now assume that the wizard on the next water tower is having 6 left. He can convert 6 liters of water into wine. And once you take this water to the next water tower, now this wizard can actually take out all this water and convert it into wine. Sorry, 5 wine, right? Converting it to five wine, and 1 energy would be left. So yeah, this can be beneficial for us, right? We have understood what we are going to do. We have understood that what we are going to do for every tower, the water which can be converted into wine, this is our main priority. Do this thing. After that, if you have some water left, take it to the right side, like take it to the next water tower. If the wizard energy left, notice that only one of these things would be left, because if both of these are left, then you can convert some more water to wine. Only one of these would be left. So if wizard energy is left, in that case, you can just uh, store it. Like it can take more water from the left. Like you can take more water from the left side and convert it into some more wine, right? Something like this. We have just seen from the problem that we can do something like this. So now coming back to solve the problem for using the segment tree, what do we have to do? We have to understand what can we store in a node of a segment tree. One thing is clear, that you would be willing to store. Okay, so let's see how you will merge two nodes first. Like we will see how we will merge two nodes, and from there we will conclude what data we need. You have, let's say you have one water tower and you have another water tower on the right, and there is a valve. This water tower has got some wine created. This water tower has also got some wine created. This water tower has some water left. Basically, it has something to give, some water it can give on the right side. And this water tower, like we are talking about these two water towers right now, this water tower had some water which it could give on the right side, and this water tower had some wizard energy left. So this water tower can actually take some water and create into wine. So maybe I can name it as what can take. So yeah, I can actually contain the amount of wine which has been created at a water tower. I can store this in a note. I can store the amount of water it can give on the right side. inside the node. I can store the amount of water it can take from the left side. One of these things would be 0, but I can actually store these three things inside a node of a segment tree. Similarly, this node on the right side will also have it. And then while merging both of these two nodes, let's say this is the left node and this is the right node. Sorry for bad handwriting. I will write cleanly now. Yeah. So for the left node and right node, how will you merge them? Let's see what we will do. The node after merging, the wine it will have is gonna be equal to left dot wine plus right dot wine, right? The amount of wine it will have is gonna be equal to the sum of the wines which both of those had, or would it be more? Actually, it would be more, because let's say it had 2 wine, like 2 liters of wine, and it had 3 liters of wine. It gave 1 liter of water to the right, and it converted that 1 liter of water into wine. So you will have 2 liters, 3 liters, and this combination. So you would actually have one more component, which is going to be the minimum of the amount of water which left can give. So left can give this thing, and the amount of water which right can take. Right can take. The node will have this much wine. Let's say this part as more wine. Like you can have better names. I'm just using the names which I used during the contest while doing the problem. Okay, so node dot wine is gonna be equal to the wine which left guy had, and wine which right guy had, and the amount of wine which has been created now. Now, can I say that these two water towers are quite similar to, just assuming that if it was like just one water tower being combined, the two water towers being combined to one water tower, it is very similar. Like you can visualize it like that also, or you can just visualize it as the nodes of a segment tree. So for the segment tree, like just see the new water tower which we are having after combining both these water towers. The amount of wine is nothing but the amount of wine I had on the left, on the right, and the amount of wine being created while combining them. The amount of water it can give on the right side is gonna be equal to right dot can give, the amount of water which can be given on the right side, plus the amount of water which left. So right dot can give is the amount of water which right had, the right water tower had to give on to the next water tower, which would obviously be like only one of them would be one, the other one would be 0. But even though, like, you can just write up it like a formula, it would be easier for us to write here like this, that the amount of water which the right guy has to give, the amount of water which the left guy had to give, and some of the water which the left guy had to give was actually being converted into wine. How much water was converted? It is being stored inside a variable more wine. So node dot can give, you can calculate it like this. And for the thing can take, it is very similar. You will just take right dot can give, left dot can give, minus more dot wine, because right uh, some energy of the wizard on the right water tower was being used in creating more wine, right? This can give is nothing but passing water on the right side. This can, sorry, this can give is nothing but passing water on the right side, passing water to right. This can take is nothing but wizard's power, which in which it takes some water and create it into wine. So Like you can just write for node dot can take also, and you will get all the three things which we required for a node, such that it can now be merged with other nodes also, other nodes also. So if you had something like a water tower which had 10 liters of wine, it could give 2 liters of wine to the right, and 2 liters of water to the right, and it could not take any water from the left side, or it could not actually convert any water to wine. And there was another water tower which could take, or let's say which had 5 liters of water, which had 5 liters of wine. It did not have any water, so that it cannot pass anything on the right now, but it had 4 liters of, 4 units of energy. The wizard had 4 units of energy. Now when you merge both of these, you will get a new water tower, something like, you can just assume it as a water tower, or basically these two water tower are now being combined in such a way that it has now um, 10 plus 5 plus minimum of 2 and 4 is 2, this much, that is 17 liters of wine, and it has no water which can be passed on, like it has consumed all his water and have converted it to wine, and it has capacity of 2 liters, like taking 2 liters of water and converting it into wine. So you can just assume this water tower you had earlier like this guy, and you can similarly just convert all, like merge all the water towers. You will have one water tower at last for the whole array, which will have some wine, right? Which will have some wine. You just care about this part. And this is what you have to print after every query. This is your answer for every query. This is something like ABC, yeah, WABC, which the problem mentioned in. Okay, so now let's look at the example. Or I think that for the people who are solving F1 problem, I don't think that it is really required. Okay, since I talked, let's say, let me just take it here also. You have 3 water towers having initially 333 amount of water. Then you have some wizards 1, 4, 2, and 8 with wine. First update which we make is just convert 4, like the 4th water tower to 38, which it initially is, already is. So what will be the amount of wine which can be generated? It will generate 1 liter of wine. It will generate 3 liters of wine. It will generate 2 liters of wine, and it will generate 3 liters of wine. Then the 2 liters of water, basically it will have 2 liters of water remaining. It will go there. 1 liter would be converted here, since it would be having 1 liter remaining. Like something like this will happen. I'm not really going to completely show this everything, but something like this will happen, that it had 3 liters of water and it had 1 unit of capacity. It just converted it. You have 2 liters of water remaining. Wine is now 1. It went on the right side. Now you have 5 liters of water. You convert 4 liter of it to wine. So now you have 5 liters of wine and 1 liter of water there. It goes on to this place. Now you have 4 liters of water. 2 liters of water will be converted into wine. So you will have 7 liters of wine. And did we make some mistake here? I guess 1 liter. Then, okay, let me confirm this. 1328. Okay. Okay, let's see what will happen. We converted 1 liter, then it went on the right side. We converted 4 of it. Then now we have 4 liters of water, and we can convert only 2 liters into wine. So we did convert it. Now we have only 2 liters of water left, and it will be passed on to the next water tank. We will have now 5 liters of water here, and the wizard can convert till 8 liters. It has only 5 liters, so it will convert all of this into wine, and you will have 12 liters of wine. Right? This is actually the solution for the first query. After that, you will just make some changes and just calculate it again. So once you create the segment tree, it will take big O of n log n time complexity for creating it, and all the subsequent queries will take only big O of log n time. So first of all, you will create a segment tree with this much time complexity. This is the building time complexity, and then this is the time complexity for the queries. So yeah, that's it. This is not very standard, but kind of standard problem. And my code here, like the code which I wrote in contest, is not so clean. I will code it again and will paste it into the description. Like you will find a cleaner code in the description. So in the segment tree template I had, I made this change. The array which I pass is actually a vector of pair of long, because we wanted to pass on two things for the node, that is the amount of water and the power of the wizard. And in the segment tree, I'm just storing these three things: wine, the amount of water it can take, the amount of water it can pass on to the next thing. Just ignore this part and these things. Like the code is not clean, I'm just telling it right now. I will give a better code. I will give a cleaner code in the description. So, okay, let me give you some idea about the template. In the template, I don't make any changes from here till here in the segment tree. Basically, the whole segment tree doesn't have any changes. The only changes is while creating the update, I'm just passing value and this long. All the changes I make are gonna be in this in these structures. So for the node I created, it has a wine, it has a variable can take and a variable can give. For the empty node, everything is 0, and for the node with some water and some the CT is nothing but can take in short form. So a node with some water and some power of wizard, the amount of wine it can create is nothing but the minimum of both of these, and the amount of water it can take from the left and convert it into wine is nothing but maximum of CT minus val and 0. Basically, in case if CT is greater than val, if the power of wizard is greater than the amount of water, then it would be something positive, otherwise it would be 0. Similarly, for can give, it is val minus CT and 0, so it would never go below 0. While merging, I'm saying that first of all, storing the amount of extra wine which we have been creating. I'm saying that wine is nothing but equal to the wine from the left, wine from the right, and the extra wine which we created. Can give is nothing but the amount of water which the right water tower could give, left water tower could give, minus the amount of wine which I've created, because I have used some powers. I have used some water here, and in the next case, I have used some uh, power here, so that's why I'm subtracting more wine here. And both of these, like one of these would be some value, some positive value, and the other one would be 0. In the update part, it is nothing different, like just doing the same stuff I did here, just doing the same stuff here. This is just the simple update query. And while taking inputs, I took the inputs in some array A, which is a pair of long, so that I can just directly pass it in the segment tree. And for the array C, like I don't know why, but I named it D, and it doesn't really have to do anything with it. It is just being created and nothing has been done. There are some DBG statements for debugging. I just then erase them while submitting the code. Then I have a while query, like I'm just going for every query, taking up P, X, Y, Z input, converting it into zero-based indexing, then updating x and y, basically the amount of water and the capacity of the uh, wizard at the index p, and updating it in the segment tree also. Updating it here is not really important. And at the end, I'm just asking for the query and printing out the number of amount of wine. And that's it for this problem. So I hope that the video tutorial will help you out. The video tutorial help you out, and you will find a cleaner solution in the description, probably by tomorrow. So thank you for watching the video, and bye bye.